Hello and welcome to the first in a series of THERMOS training videos. This video is about getting started with THERMOS. Afterwards, you should have learned how to create an account on THERMOS, how to start a THERMOS project and what a project is for, how to create a THERMOS demand map from OpenStreetMap data, and how to draw a heat network and evaluate it. To start using the THERMOS, you need an account. Go to your web browser and type tool.thermos-project.eu. You should see a page like the one shown. To create your account, all you need to do is enter an email address and a password and click Create. This will make you an account and log you in. This will also take you through to the THERMOS homepage, where your projects will be shown. You can tell THERMOS your name as well if you click on Settings. Here you can change your name to a friendly shorthand, which will appear for your colleagues to see. All work in THERMOS is contained in projects. A project is a place where several people can share the same work. Everyone who has access to a project can see and modify all of the work in that project. To make a new project from the THERMOS homepage, click on New Project. Every project has to have a name, so let's write one in. There's also a box for project description, which could be a short description about what you're going to be mapping, and a list of people to invite to participate, although these are both optional. The brand new project we just created has nothing in it yet. To do any heat network modelling, we need to add a demand map. This is a map of an area in which we want to design a heat network, which describes the location of heat demand and pipe routes. First we click Map near the top of the page, and then this starts the process of creating the map. So we have to enter a name for the map before we can continue. And then there's also a box for a description as well. Here we select where our buildings and roads come from. This will define our choices for the supply and demand locations. In this exercise, we will be taking buildings from OpenStreetMap, which is a public project to create a world map. The other option here is to upload your own GIS data if you have it. I'm going to use the search box to search for Bristol, and then it's come up with the administrative boundaries, and then I'm going to zoom in to try and select a smaller area. So I can press the Shift key and draw a rectangle over the centre of Bristol. And then I'll use this rectangle to select an area. Now this is where the tool checks for your LiDAR coverage. LiDAR is used to calculate building heights and volumes for the heat demand estimation. This is not required, but it's likely to improve the quality of the demand estimates. What it looks like is where there is LiDAR coverage, there is a purple box drawn over it, like where this is a box, it will be the purple one. So in this case, there isn't any LiDAR data here. But you have the option to add your own LiDAR tiles. Here we have the heating degree days. You can find these online, for example, at degreedays.net. And just note here that this is relative to a 17 degrees Celsius base temperature. There's also the ability to automatically assign buildings into the same road as a group. This will mean that THERMOS will make the decision either to connect all of the buildings in a road or none of them. You can also group buildings manually within the map, so I'm going to leave that unticked. Okay, now it's going to take a few seconds to produce the map. So one of the things you can do with THERMOS is to draw a heat network and ask THERMOS how good it is. Let's do this now in the map we've just created. First click the Heat Net button to create a new network. So the network design page is now shown, centered on the area we imported from OpenStreetMap. The network design page is divided into three main parts. In the top left, you've got this map. You can use the map to select and manipulate buildings and paths for your network. On the right is a selection information page, which is currently empty. We use this to show information about particular buildings and paths that we've clicked on. And then at the bottom, we've got a candidate table, which is also currently empty. This shows information about the particular buildings and paths we're thinking of including in our network. Within the map, there are several controls which you can use to show what is presented. On the top right, we've got a search box so you can find places in the map. Below that are the layer controls, which let you hide and show different types of information. So these top three are base maps, so we've got satellite, an OpenStreetMap, and no base map. And below that we have candidates, which are the buildings and roads. You can get a heat map to show you where the dense areas of heat demand are, and labels, so you can get road names and place names. In the top left, we've got the buttons to zoom in and zoom out. However, you can also use your mouse scroll wheel, and you can zoom into a rectangle by holding down the Shift key and drawing a box. We've also got selection types, hiding unconstrained candidates, zooming to selections, and drawing new buildings, but we'll cover them in a second. To ask THERMOS about a network, we need to tell it which buildings and which paths we're thinking about using. This is a two-step process. First, we need to select some candidates using the map, and next we need to mark these candidates as part of a network. So let's look at selecting some buildings. The simplest way to select something is by clicking on it. You can see now the map with the selected building has a thicker line around it and is drawn in a darker shade. On the right, we've got the selection info panel, which shows some information about the selected building. And if we select a path instead, you'll see how the selection pane changes. There's slightly different information about paths and buildings. To add candidates to the network, select them and press the letter C. Pressing the letter C repeatedly will change their colour from grey to blue and blue to red, and then back to grey. Grey things are not being considered. In this case, they're called forbidden. Blue things can be connected to the network if the model thinks it's a good idea, so these are optional. And red things must be connected to the network if it is possible, so these are required. You can select big areas using the two area selection tools on the left of the map. The first is the polygon tool, which lets you select an irregular area. So you can draw a shape, and that will select everything within the shape. And then the other one is the rectangle, that will just draw a rectangle and select everything within that. So once you have chosen a shape to select all the buildings within, I'm going to change them to optional, and then we can hide everything else, all of the unconstrained candidates, like this. Next, let's evaluate a network which connects up these buildings. There are two more steps left to do that. First, we need to define a heat supply location. So let's select one of the buildings on the map and press the S key to convert it into a supply. So this is showing a small window containing the supply parameters. So I'm going to put in some random parameters, 3 megawatt maximum capacity, fixed cost in here is 100,000, which is then a million, because it's 1,000 per currency. And then we'll go with a capacity cost of 300 currency per kilowatt of capacity. And then we'll do a supply cost of 4 cents per kilowatt hour for producing the heat at that cost. And we'll put 300 grams per kilowatt hour of CO2. So pressing OK saves all the supply parameters, and now the building is coloured in orange to show us the supply location. Let's use a different constraint status. So far we've set everything to optional. In this configuration, THERMOS will try and select a set of optional components that maximise the network's net present value. We'll cover that in more detail next time, but for now let's say we want to build a network that connects all of these buildings no matter the cost. To do this we have to select them all and change their constraint to required. You may be thinking this could require a lot of clicking on the map, but it can be done in a few simple steps. First we want to select all of the candidates, so there's a keyboard shortcut for this by pressing A. And now this has selected everything, but however we only want buildings. So to restrict the selection just to buildings, you can use the selection info panel to remove the paths by either clicking on the cross on the paths or by clicking on demand. So now we just buildings, I'm going to press C to bring them all to be required. Now to get the network to run, we need to give it a name and press save. Now we click Optimize Network in the top right. So you can see here you've got Optimize Network or Optimize Supply, or both. In this case, we're just going to do the network, and we'll cover optimizing the supply another time. So sometimes this can take a few minutes to run. When there's fewer buildings, it doesn't take as long. So we can see the network has run because down below we've got Constraints and Solution tabs. So this Constraints tab just looks how I created it, with the blue paths and the red buildings. The colours in the Solution tab are slightly different. So here we've got a map legend that you can use to refer back to, but I'll talk you through it. So we've got these dark orange are anything that's connected within the network, so it's been included. So these are paths and buildings. There's a pale brown or beige colour which shows the buildings and paths that have not been included but could have been. They were just chosen, there were other more preferable routes. The magenta or purple signifies elements that were impossible to connect to the network. Usually this is because there isn't a route from the supply location to the building or path, therefore could not have been connected. So you can see in this case there's clearly no path to this building. In this case there is the ability to add a path which could enable more buildings to be included. So if I use this draw a new connector, you can just click on the path, click on the building, and it will draw a line. I'll do this in the constraints page and just make sure that it is optional to be included. There's also the ability to add a building candidate, for example if there's a new development that you'd like to connect to the network. So that's by clicking on the draw a new building, selecting where you want to put it, and just remember to connect this up with a path, otherwise it won't be included. So you can enter details regarding the heat demand when you press E for edit. To edit the details you need to tick the box to show which bits you'd like to change and then click save. So we can either change, for example, the heat demand and the peak, and then press OK. Finally, just to show, there is a panel on the left when you click on the THERMOS logo. You can find out more information about the chosen network, including the MPV. You can also download the network as an Excel spreadsheet or a GeoJSON. Hopefully this video has helped you get started with the THERMOS tool, and you should now be able to draw your own heat network.